Hey guys, today we're going to be taking some notes over section 1F, so we're doing the second part of unit 1 here. And these notes will be about translating between words and math, or math and words, going both ways. The reason that this is important is because when we do problem solving, we want to be able to make those transitions. We want to be able to read a problem and figure out what it's asking us to do, and so that's why this is a really important skill. You can see here I had a little problem with my copying that I didn't notice until after I was done, so this should say written words down here. We're going to start up at the top here, and we're going to take a numerical expression. So an expression is just a math problem that doesn't have an equal sign. So I'm going to take the numerical expression 37 plus 28. Now there are several ways. This is a numerical expression, so this is written in math terms. There are several ways that we could talk about this problem using words. We could say 28 added to 37. We could say 37 plus 28. We could say the sum of 37 and 28. Put a little dot here so you can see the difference between my choices. And then we could say 28 more than 37. I'm going to go ahead and underline those words that would mean add, that we would use the plus sign for. So you see the word added there. You see the word plus. You see the word sum, which is the answer to an addition problem. And then you see those words more than. So if we have an amount and we want something more than that, that would be an addition. I'm going to skip this second part down here for just a minute. I'm going to go over to the subtraction area here. And so my numerical expression will be 90 minus 12. And a possible way that I could write that is 12 subtracted from 90. So that one's one that kids often kind of get confused. 12 subtracted from 90. Another way to say that would be 12 less than 90. So 12 less than 90. And that's one of the tough ones. Kids kind of get those confused sometimes. The difference of 90 and 12. Would be another way to write that. And of course the good old 90 minus 12, of course. Or how about take 12 away from 90? Okay, so words that would indicate that we need to subtract, right? Subtracted from, less than, difference, and then take away would all be subtraction terms. All right, so let's look at some multiplication. Now, multiplication, we're getting ourselves ready for some algebra here, and so we want to know some different ways that we can write multiplication problems. So we could do a problem that looks like 8 times 48. We could do a dot, and that would look like this. That means multiplication also. And the reason that they switch the x out for the dot is because in algebra a lot of times we use variables, and an x is often a variable for us, and so we don't want to use x as the multiplication symbol, and so they switch it for a dot. Sometimes they'll use parentheses. You might see something that looks like this, and we did see that in our last unit. That would mean 8 times 48 as well. Or you might even see both numbers in parentheses. Or maybe they'll switch it around and the 8's in parentheses and the 48 is not. So all of those would mean multiplication. All right, so for the words, we could write 8 times 48, we could write 48 multiplied by 8. We could write the product of 8 and 48. Or we could write 8 groups of 48. So you can see there we've got the times would mean multiply. Of course, the word multiplied by would mean multiply. Product is the answer to a multiplication problem. And then when we're doing groups of things. All right, our last one then. We've got 327 divided by 3. This is one way you might see division. Another way you might see division is using a fraction bar, 327, and then a fraction bar, 3. That's another way that division can be written as well, and that's pretty common. All right, so division phrases would be 327 divided by 3. Or, of course, you might have the quotient of 327 and 3. Or you may have divided into equal groups. So 327 divided into equal groups. Into 3 equal groups. All of those would indicate to you that you need to do a division problem to solve that out. So 327 divided by the quotient of, or divided into equal groups. Anytime you see that divided into equal groups, that's going to be a division problem. All right, now algebraic expressions. So algebraic expressions are math problems that use variables instead of a number. So they use a variable in place of a number. Variables are just letters that we put in place of numbers. And so an example would be x plus 28. And so one way to write that, an example of that would be 28 added to x. And of course we could use any of these phrases up here and just replace the x and the 28 into those phrases. Okay. Another algebraic expression might look like this, k minus 12. And a way to write that one might be k minus 12, or 12 subtracted from k, or 12 less than k. All right, then we've got algebraic expressions with multiplication. So we could have 8 times w. We could have 8 times w. We could even just have 8w. When we're doing algebra and you see a letter and a number together like this, then they mean multiplication. So this is 8 times w. All right, and then finally our last one, we could have n divided by 3 or n divided by 3. And one way to write that then would be the quotient of n and 3. All right. Tune into the next video for the rest of these notes.